Hi guys, this is a follow-up to my video about how to use a potentiometer to control the rate of flashing of an LED using an Arduino. In this video, I'm going to have a look at some of the different sensors that we can connect to an Arduino. And I'll start off with the temperature sensor. Now, connecting the temperature sensor to the Arduino is similar to the potentiometer that we used before. That's because the temperature sensor also has 3 legs. However, unlike the potentiometer, you have to make sure that you connect the legs in the correct order. So the legs are labelled. If you hover over the first leg, you'll see it says power. That means it needs to connect to the positive 3.3 volts on the Arduino. The rightmost leg says ground, so we connect that to the ground. Now the middle leg is where we get the actual value from the sensor. So this is going to indicate to us the temperature. And we connect the middle leg to pin A0 on the Arduino. And that's going to go through an analog to digital converter, and it will be a value that the microprocessor can read. So now we need to use the microprocessor to examine the value from the sensor. I'm going to click on code, and I'm going to choose the forever box. Now let's create a variable. So I've actually made a variable already called pin A0, so let's use that. And what I want to do is set pin A0 to the value that I read from analog pin A0. So what that means is that the temperature sensor value is going into pin A0, it's being converted into a number by the analog to digital converter, and then the microprocessor is going to store that value in a variable called pin A0. And let's just print on the screen what that variable is. So I'm going to choose the print to serial monitor command, and then I'll put pin A0 as the variable that I want to print out. If I click on Start Simulation, so we can see there it says 153, and if I click on the temperature sensor, increasing the temperature increases that number, decreasing the temperature decreases that number. Okay, so that's very similar to what we did with the potentiometer. But not all sensors have 3 legs. Some sensors only have 2 legs. So let's look at how we can connect those. So I'm going to delete the temperature sensor, and instead we'll have a look at the photoresistor. Now a photoresistor is a resistor that changes its value depending upon how bright the environment is. And it only has 2 legs. So this is a little bit more tricky to connect to the Arduino. But actually all you need is another resistor. So we grab a second resistor and put it down here. And then we join one of the legs of the photoresistor to our normal resistor. This creates a sensor with 3 legs because now the first leg is the left leg of the resistor, and just like before we're going to connect that to 3.3 volts. The middle leg is actually where the 2 things are joined together. So I'm just going to grab the end of that and connect that to A0. Just like before we connected the middle pin of the temperature sensor to A0. And then the final leg is the bottom of the resistor. So I'm going to grab that and connect it to ground. Now those lines are overlapping in the diagram, but they're not actually connected. So these are 2 separate wires. Just to make that clear, I'm going to change the color of this wire to black. Okay, now I'm not going to change the code at all. So we're still just printing to the serial monitor the value that we get from the sensor. If I click Start Simulation, you can see that I'm getting the value 4 from the sensor, and that's because at the moment it's very dark. If I make it brighter, then the value that we get from the photoresistor increases, and eventually we go up to a maximum of 448. As it gets darker, that value goes back down again. So this actually works just the same as with the temperature sensor. The only catch is that we had to add in this extra resistor. Okay, so now let's have a look at how we can use a sensor to control an output device again. So I'm going to delete these and go back to the temperature sensor. If I grab that temperature sensor and put it over here, and we'll connect it up just the same way that we did before. So the positive terminal is going to 3.3 volts, the ground terminal is going to the ground, and the middle terminal is going to A0. Okay, now remember that when we ran the program, this was printing out values, and I can actually click on the temperature sensor and change the temperature and see what value appears. Now, the value that appears is not in degrees centigrade. That value does change as I change the temperature, but it's not actually the number that represents the temperature. So if I want to find out what number here corresponds to a temperature, the easiest way is just to pick a temperature and then see what number I get. So if I wanted to do 30 degrees centigrade, I can zoom in on my temperature sensor, move it to 30 degrees centigrade, and then I can see that that 30 degrees centigrade corresponds to 164 on the pin A0. So let's say that I have a fan, and when the fan spins, I can use that to cool down the room. So what I want to do is read the temperature sensor, and if the temperature sensor is above 30 degrees centigrade, I want to turn on the fan. And if the temperature sensor is below 30 degrees centigrade, I want to turn off the fan. Well, that's easy to do. First of all, let's get a motor which can power our fan. I'm going to pick the DC motor and drag it over here. And then if we look at the DC motor, we've got a positive terminal, that's the red one, and I connect that to pin 7. And we've got a negative terminal which I connect to ground. Now, just like with the LED, we can turn the motor by creating an electronic circuit. We tell the Arduino to power pin 7, and then electricity will flow from pin 7 through the motor and out to the ground, and that will turn the motor. So now to make that happen, I need to go to the code, and I go to output and set pin 7 to high. When I run the program, we can see that it is still reading the temperature, but also because pin 7 has been set to high, that's making the motor turn. Now let's say we only want the motor to turn when the temperature is above 30 degrees centigrade. It's easy to do that because we have a microprocessor here. We can easily use an if-else statement to check the value that we read from the temperature sensor. Now we know that 30 degrees centigrade corresponds to the value 153. So I just go to maths and then pull across one of these comparison boxes. And I want to compare the variable which stores the temperature sensor value to the number 153. Now, if it's greater than 153, then I want to set pin 7 to high, and that will turn the motor. And if it's less than 153, then I want to set pin 7 to low, and that will turn the motor off. So let's test it out. I click on Start Simulation. Now, when I get those errors, it's just the internet connection not working. There we go. Okay, so I click on Temperature Sensor. I might need to just move this a little bit so you can see the motor. So click on the temperature sensor. Now, at the moment, it's quite cool, so the fan is not running. But if we go over 30 degrees C, you see the fan turns on. And then as the temperature goes down, when it drops below 30 degrees C, the fan turns off again. Above 30, it's on. Below 30, it's off. That's all being controlled by this if statement. So I hope all of that makes sense. Now, the most likely question you are to receive on this in the exam is a question where you have to describe the process of how the sensor is connected to the microprocessor and then to the output device. So as an example, we could describe this in the following way. The temperature sensor records the temperature in the environment and outputs an analog value. The analog value goes into an analog to digital converter where it's converted into a number that the microprocessor can read. The microprocessor runs a program which compares the value from the sensor against a value stored in its program. If the value from the sensor is above the value stored in the program, then the microprocessor will output a signal which controls the motor and turns it on. If the value from the sensor is below the stored value in the program, then the microprocessor will turn off the output and the motor will stop. Okay, so guys, I hope that all makes sense, and I'll leave it there.